we're going to be looking at systems in 3 variables and Gaussian elimination. So systems in 3 variables will be very similar to what you've done with systems of equations with 2 equations and 2 variables. In that case, you solve for x and y and you used substitution and elimination. And we do the same thing here with our systems of equations in 3 variables. The difference is that we're going to have to use more than one combination, basically. So I'm going to number these 1, 2, and 3 so that you can kind of follow along. So when I'm doing just system in 3 variables, I don't have to think about a certain process. I just think about, can I start to eliminate variables? So if I look at equation 2 and equation 3, if I were to take those 2 equations, x minus 3y plus 10z equals 40, and negative x plus 3y minus 5z equals 30, and combine rows, these are going to cancel, these are going to cancel. I would have 5z equals 70, divide both sides by 5, and z would be equal to 14. Now that was actually nice and really easy because I didn't have to do a lot of work and I've already solved for a variable. Sometimes you may have to take equations 1 and 2 and also cancel the same variable in order to be able then to keep working. So for the next step, then I would take equation 1 and equation 3. Now the reason that I'm doing that is because these y values are going to cancel without me having to multiply this equation by a number. So with elimination, sometimes if they won't cancel, remember you have to multiply by something so that they would cancel. In this case, these are going to do that without me having to do any work. So I would have 2x plus 1z is equal to 50 when I add those equations together. I know that z is 14, so we're going to make that substitution. I would subtract that from both sides, divide by 2, and so I know that x is equal to 18. So then the last step is just to go back and pick one of these 3 original equations. It doesn't matter. I'm going to take equation 2. I plug in 18 for x. I'm going to plug in 14 for z. And then we're just going to solve this equation for y. So that's 140 negative 3y plus 158 is equal to 40. Negative 3y is equal to negative 118. Divide both sides by negative 3. And we end up with 39 and a third. So again, for these problems, you can do lots of combinations, lots of different steps to get you to that solution. So when we get to the next step, which is Gaussian elimination, we want a triangular form. So x plus y plus z is equal to something, y plus z in the second row, and then just a single variable z. And so as you can see, that's our nice kind of triangle. So the steps that we are allowed to perform are, we can interchange any 2 rows. So let's say that you're working and you get an equation with just z up in the first row. We can say, well, I want that to go down into the 3rd row so that I can get it in this particular form. So we can move rows around. We can multiply by any non-zero real number. So thinking elimination, if I needed it to cancel and it needed a negative 3 in front of the x, I multiply the entire row by negative 3. And then I can add those 2 rows together to cancel that variable. So again, the process is the same. We're just formalizing it a little bit to this method called Gaussian elimination. So for this problem, one thing that we want to think about is, we could take z and we could cancel that out, but we can see here that with Gaussian elimination, I don't want that to happen. So I want to look at what is it that I need to multiply the first and second row by to start to eliminate some variables. So I kind of start on the left side and work my way in. So with just regular systems of equations, we can kind of pick and choose where we want to work from. This one we're going to be very particular. So I want to eliminate the x in that first and second row. So we're going to take and multiply row 1 by -3, and we're going to add it to row 2. So when I take and start to combine, we're going to let this new row that we're creating take place of row 2. So I'm going to copy row 1 again, just like it is. And then I'm going to actually perform this operation that I have over the arrow, and that's going to go into row 2. So -3x plus 3x is going to give me 0x. -2 times -3 is positive 6y. Positive 6y take away 5y is going to leave me just with y. -3z plus z is going to leave me with -2z. And then we also have to multiply the 21. So not 21, multiply 7 by -3 to get -21. And -21 plus 14 is going to give me -7. And we didn't do anything with with row 3. So we're going to leave row 3 as is. Then we're going to take row 1 and 3, because again I need to eliminate another variable, with specifically x. So in order to do that, I'm going to have to take -2 times row 1 and add that to row 3. Again, we're going to carry what we've already started to build to this triangular form in row 1 and 2 and leave that the same. And then we're going to perform this operation here, and then we're going to make that be row 3. So -2x and 2x are going to cancel, so I have 0x. -2 times -2 is positive 4. Positive 4 minus 2 is going to leave me with 2y. -2z minus 3z, or minus z, is going to give me -3z. And then -14 and 3 results in -11. So now I have equations, or rows 2 and 3, that have y and z. I need to eliminate y in the third row so that I can get up to this triangular form. So we're going to work with row 2, and I would have to multiply that by -2 and add it to row 3 in order for y to cancel. So the first row stays the same. Second row stays the same. And then for the third row, we're going to say -2y, positive 2y are going to cancel. -2 and -2z is 4z. Added to -3z is going to leave me with z. -2 and -7 is positive 14. 14 minus 11 is 3. So at this point, we have completed Gaussian elimination. We've put this in triangular form because we have x, y, z in the first row, y and z in the second, and z in the third. So the last step is going to be just like we were doing before, and we're going to take and plug in what we know. So if z is equal to 3, we can plug that into the second row. And add 6 to both sides, so y is equal to -1. We can use the original equation, so I'm going to go back to row 1, so x minus 2 plug in -1 for y, plug in 3 for z, equals 7. So 2 and 3 would be 5, subtract 5, x is equal to 2. So the final solution as an ordered triple is 2, -1, 3. So again, it's not work that you haven't done. It's just a lot of it kind of all together. I would definitely recommend practicing just systems of equations first before you try the Gaussian elimination. So this is the problem that we did just a minute ago. We're going to go back and we're going to do that same problem using Gaussian elimination. So if I look at row 2 and row 3, if I add those together, I can cancel x really easily. So we're going to add row 2 and row 3. Again, we just write and carry over the first 2 rows because we're not doing anything with those. We just keep them and save those basically for later work. Okay, so if I add row 2 and row 3, the x's are going to cancel, the y's are going to cancel, and then we would get 5z is equal to 70. We want to multiply row 3 by 1/5 so that we have just z. And we know that z is equal to 14. So at the next step, we need to cancel x in the second row. So we can do that by taking row 1 and adding it to -3 times row 2. So row 1 stays the same. Row 2 is now going to become this combination. So if I add the 3x and -3x together, they cancel. -3 plus 9y is going to give me 6y. 6 and -30 is going to give me -24z, which is going to be equal to